Next, I want to move on to a very important topic. Now, this is a picture of a very dear character to me that I love and adore, Willy Wonka. And he has this great quote: "No one should ever, ever doubt. No one should never, never doubt what you should never, never doubt what no one is certain about." Now, what that means here and how as it applies to breath testing is every time you try a breath test case, the government is going to try and introduce evidence against your client that their blood alcohol concentration was a very certain number, 0.14, 0.17. But there's a very important principle that you have to understand, and that's the principle of uncertainty of measurement. Let me explain what that means. No matter what device you're using, whether it's comes from NASA and it's used in outer space or it's your bathroom scale, there is a principle of uncertainty of measurement. Now, let me give you an example of what I'm talking about. I recently lost about 50 pounds. And when I got down to under 200, first, I didn't even realize my scale went below 200. Seeing that number 199, that was quite an observation. So I wanted to take a picture of it. So I got off my scale. I got the camera to take a picture of it. I put the camera on the towel bar because I knew that the camera was going to weigh a little bit. So I got on, it's a digital scale, right? So I wanted to take a picture while the image was still there. And the next time I got on the scale, what do you think it read? 200. I know it's going to say 199 because it just said 199. So I get off, I allow it to reset, got back on, 200. I'm telling you, I did it 4 or 5 times and I couldn't get the darn thing to say 199 again. So 2 things happened that day. One is I didn't eat anything the rest of the day. The other thing is I had a little story that I could tell people about the uncertainty of measurement. Machines have uncertainty, right? They don't necessarily give you the number within a certain degree of precision. There's always an uncertainty of measurement, no matter what the device is. So if you're doing a blood test case, you'll see that from a lab, they always give you their uncertainty calculations for that device. But in breath testing, for some reason, they never report their error margins. And I don't call it an error margin, but they do. Let me explain to you why I don't call it an error margin. Didi Gregorius was a great shortstop for the New York Yankees. He could go a whole season potentially, and not make an error. That's why they call it an error. Because a shortstop in baseball, that's why it's an error. When they make one, it's an error. It's not an error margin because it's impossible to have complete accuracy, so it's a margin of uncertainty. The VAC is never exact. Now, why is this important for you to understand? It's important for you to understand because you need to know that this is not an exact science as you start to challenge these cases. You need to understand that the government and the district attorney is trying to make their evidence look better than it is. There's both intrinsic uncertainty and there is variability in breath testing. And what they like to do is they like to make sure that you pay no attention to the man behind the curtain, right? This is that great scene from The Wizard of Oz when Dorothy, Toto, the Scarecrow, the Cowardly Lion, they return to the wizard with the Wicked Witch of the West broomstick. Remember, he sends them on the mission, go get me the Wicked Witch of the West broomstick, and I will send you home. I'll give you a heart. I'll give you courage. I'll give you a brain, because he doesn't think they can accomplish the goal. Lo and behold, what do? They come back. He knows he can't do those things. He says, go away. What does Toto do? Toto's the hero. Toto opens up the curtain, reveals that the wizard is not really a wizard. He's just a man pulling levers. And that's what I want to do for you today. I want to reveal the curtain, and I want to show you some of these uncertainties. The first one is the general uncertainty that these devices are not. Marissa Tomei and my cousin Vinny used the term balls on accurate, from NASA. And that's what we're talking about here. That's what we're talking about here. Funny story. I was listening to Neil deGrasse Tyson the other day, and he was telling the story on Masterclass about the discovery of Neptune. They found Neptune because they noticed that Uranus's orbit around the sun was not consistent with Newton's law of gravity. So they knew there must be a planet outside of it. And then they realized that Neptune's orbit around the sun was different as well. So the scientists knew that there must be another planet outside of it. So they knew that there was this other planet which was Pluto, right? And they knew where in the sky Pluto was. So they pointed the telescope right at it. And sure enough, they looked in that right spot and they found it. Now, at that time, they couldn't actually determine the size of the planet when it was found, but they knew from the calculations, the mathematical calculations using Isaac Newton's law of gravity, that in order for it to be affecting the gravitational pull of um, of Neptune as much as it was, that it had to be as large as the planet Earth. I know what you're thinking. Pluto's not as large as the planet Earth. It's tiny. It's a dwarf planet. In fact, it's not even a planet anymore. But for years, scientists, right? Serious scientists thought that it was. And children in classes, including myself, grew up studying the fact that Pluto was a planet, and they thought it was the size of the Earth based upon these calculations. So you know what happened? In 1993, another scientist started to look at the data to figure out, why this mistake happened, and they started looking for this other planet, Planet X. Everybody thought there must be a Planet X because they knew that Neptune's orbitational path was being altered and there had to be an explanation for it. Well, when they looked at the data from the telescopes that was showing how Neptune was off, one of the three telescopes that they were using wasn't calibrated properly and the information wasn't correct. And the bottom line is, if you're using the wrong information, you're going to get the wrong results. And that's what this is all about. That's what breath testing is about. If you can understand that the top scientists in the world can be relying upon the wrong information, and that we could think that there's another planet, you don't think that police officers and local precincts can get a breath test wrong on one of these boxes? Of course they can.